I'm calling this Thinking Beyond Humanity Steps Toward Understanding Other Ways of Being. The title is a pun because we're thinking beyond humanity, but we're also talking about thinking beyond humanity, like intelligence that is not human intelligence. I'm an educated intermediate in physics and software development. I did get an A in vector calculus and linear algebra 20 something years ago. And I know my way around the AI software world relatively well. But mostly, I'm a cross cultural philosopher of religion. So, keep that in your context as you try to figure out how you should interpret what I'm going to be talking about today. When I say cross cultural philosophy of religion, I mean I am trying to pay attention to what I call the Western two-party system, but also things that are not that, in particular, Indic and indigenous traditions as best I can. When I say the Western two-party system, the basic assumption of Western mind is that you're either an anthropocentric materialist, in which case the universe is by and large unconscious except for humans, and we kind of hesitate to expand the notion of the moral community beyond humans. Some of us hesitate to expand the moral community to include all humans. But those of us who are trying to get beyond that basic mindset have a number of different options. Not only the one that is presented as the only viable alternative in the Western mind is some kind of Abrahamic monotheism in which there is a God, a personal God, and there's humans and other spiritual beings like angels and cherubim and seraphim and jinn and things like that. But this is very much, as is true of many dichotomies, perhaps most dichotomies, this is a false dichotomy. Our choices are not between materialism and Abrahamic monotheism or agnosticism, between those two. And I think studying especially the traditions coming out of India, Hinduism, Buddhism, and Jainism, as well as studying indigenous traditions like the Navajo, can be helpful in expanding our aperture in understanding what all the options are. Now, don't worry, we're mostly just talking about humans and ants and AI today. I'm not going to get into that expanded terrain, but just so you know a little about me, I try to think with that expanded terrain in the background. So I want to start out with hopefully relatively familiar territory. What's it like to be a human? First of all, humans change a lot over time. We kind of take as the standard paradigm the healthy human adult, but we all know that we were once smaller and less capable beings. Eventually, if you go back far enough, we existed in the wombs of our mothers, and prior to that, we have, the earliest you could say a human individual begins would be when the unique sperm egg pair joins, and that begins the biology. I'm not getting into any of the complicated moral issues at the beginning of life, but there is an important sense in which every human organism begins at the moment of conception. We, of course, then grow older and eventually become capacitated, and then incapacitated. What is capacitated? I guess to have capacities, anyways. And then we die. Now, that much is non-controversial. What happens other than that is controversial. Some of us believe that there is some important sense in which people move beyond death into some kind of an afterlife. Some of us believe that we might be reborn into another life. There's also a kind of multiples or all of the above option that I like to think about because I try to avoid false dichotomies. But this is a well-known fact about humans. Humans are also organisms within ecosystems. So when I say an organism, we know that this thing is not a singular entity, that it is made up of other entities. At least we have a brain, we have a heart, we have guts, for instance. And each of those is also made up of smaller things. They're made up of cells, for instance. And not all of those cells, it's important to realize, are human cells. Some of those cells are bacterial cells with entirely different DNA than the rest of the body's cells. And we shouldn't actually think about those cells as not a part of our body, as somehow alien to our body, because our body requires them in order to function properly. So we are actually not merely human beings. We are an ecosystem of human cells and non-human cells that function together in order to bring about the functions that human bodies can carry out. We also know that below that there are molecules made up of atoms, and beyond that we start to lose our grip on saying exactly what there might be. We also do know that human bodies exist as part of larger entities. We live on a planet that surrounds a sun. We're part of this solar system. That solar system is part of galaxies. Who knows how many galaxies and large-scale structures there are? Ultimately, we know very little about the very, very small and the very, very large. I in no way want to diminish what we've learned from the sciences. Long live science. May we learn many things using the scientific method. But I just want to recognize that at the very small end of the scope and the very large end of the scope, we do begin to lose our grip on what exactly is going on. Humans experience punctuated consciousness. Nothing surprising here. We all know this. When you get tired at the end of Sunday, you get into your bed and you close your eyes and your consciousness largely turns off in some important way, and then you wake up on Monday. We know that there are breaks in our conscious experience. Now, we also know that if I were to sneak into your room, I promise not to do this, and start cutting open your chest and trying to get into your internal organs, you will wake up and start screaming, but not if we properly sedate you in a medical context. So we know that even in higher breaks or more significant breaks of consciousness between Sunday and Monday, we're inclined to say that you are the same person. Okay, so far so good. I want to do just a little tiny bit of ethics here. This is my, my dissertation work. In as much as I've done anything like really academically rigorous, it's been in Aristotelian virtue ethics. I just want to give you one quick quote here, because once we've talked about what humans are, we can start to ask questions about what is good or bad for humans and how humans ought to be treated. And this particular view from Aristotle has been tremendously influential over the past several decades, but also over the past many centuries in thinking about meaning and purpose and value and what's good and bad for things. So this is just a quote from the Nicomachean Ethics. The good of man is the active exercise of soul in accordance with excellence or virtue over a complete lifetime. The man thing, yes, he said that. Aristotle's famously misogynistic, so we should get rid of that. The soul thing is a bit complicated in order to understand what Aristotle means by soul. So let me just blow this out a little bit and say a broader Aristotelian or sort of neo-Aristotelian, generalized Aristotelian view looks like this. The good of a being is the active exercise of their characteristic functions in accordance with excellence or virtue over a complete lifetime. And I'm going to suggest that this kind of a model can be helpful for us in thinking about any kind of entity, because what that entity is will be defined in terms of its characteristic functions, and then what is good or bad for that entity can be determined by whether or not those functions are being carried out excellently or virtuously over the scope of that whole entity's normal lifetime. All right. So now we need to start getting a little more complicated and start talking about some stuff that's not human. I want to talk about what it's like to be an ant. I'm very interested and inspired by the work of Bert Holdobler and E.O. Wilson in this book called The Ants and other things that they've done. If we think about ants as individual entities, then we should recognize that ants are basically just wasps. I mean this in the technical sense, like they are just a subset of various wasp orders. They just, generally speaking, don't have wings or stingers, but they fall into this general category. And, wasps are sometimes colonial organisms and sometimes not colonial organisms. But the ants are hyper-colonial, and in fact so colonial that ant colonies perhaps should be considered superorganisms. This is at least what Holdobler and Wilson suggest. So a superorganism is sort of like an organism. My organism is made up of other organisms. It's made up of cells, which are made up of tissues. My body is made up of organs, which are made up of tissues, which are made up of cells, right? So this organism is made of other organisms. So a superorganism is something at a level higher than that, something that is made up of individual organisms, in this case, individual ants. So the superorganism of the ant colony has a singular location for its reproductive capacities. It's inside of the queen. Some of the specific movement or battle tasks are carried out by certain types of ant shapes with larger bodies and different shaped heads and rougher pincers and things like this. These are all the same species. It's just that the individual bodies of the ants are specialized for special purposes. At one very extreme version of this, there are honeypot ants. Some members of those colonies actually, all they do is they're suspended from the ceiling and their bodies contain nutritious liquids as storage. They're living jars, essentially. So the suggestion here is, although as humans, it's most natural for us to think about the individual ants as individual organisms, that we shouldn't really think about this, that actually the whole group, the whole colony is something else. Really, the unit we should be thinking of is the superorganismal colony. Now, that introduces some very complicated philosophical questions, which are going to be very relevant for what we're going to talk about here today. Because if what you are is a superorganism made up of organisms, then it's actually quite easy for you to undergo fission. That is, the superorganism can split into two suborganisms. And this does actually happen in the world of ants. They actually do break apart into multiple colonies. You can also undergo fusion. So you can have two colonies which merge into one. In the ant world, sometimes colonies go to war with each other. They'll kill the queen of a colony, and then they'll take everybody else from that colony into theirs. So we can see that there are these complicated entities, metaphysically complicated entities, which are composites of the individual organisms. And if we have things like that, then they can split and they can fuse in ways that make sense to us, but are going to get puzzling as we move forward. Furthermore, ants are special in the fact that they are the only organisms other than humans here on Earth that we know of who have engaged in farming. They use plants. The leafcutter ants in particular will cut up plants and bring them back to their colonies so that they can grow a fungus that they eat. They also tend herds. They have domesticated aphids and mealybugs and a couple of other things. So aphids are sort of the most famous instance of this, where these have co-evolved with each other, that at some point we really need to start wondering how to think about the relationship between them. And I think this sort of Aristotelian view can be helpful again, right? So the good of a being is the active exercise of functions. Well, you can see here that when we start looking at what it takes for an ant to flourish, you can't actually define that at the instance of an individual ant. You have to think about the whole colony, because the different parts of what characterize ant flourishing are distributed across multiple individual organisms. So the being itself is something bigger than an individual ant, but you might also wonder if it's bigger than the ant colony, because really, if you don't have the leaves and the fungus and the aphids around, then the whole system won't break down. I know I'm also kind of blurring over distinctions between individual ant species. I don't think it's true that the leafcutter ants also domesticated aphids, but you understand what I'm trying to get at here. Okay. So what I want to talk to you about is this principle. This is not a misprint of the word Ant-Man. This is the Sanskrit word Anatman, which is in Buddhism sometimes translated into English as no self. And it's kind of difficult for Westerners especially to understand what this idea of no self in Buddhism means. Basically, the idea is, as noted a minute ago, a human is an aggregate of aggregates, a collection of collections. I'll go through these very quickly. We have a physical body, a material body. We have internal sensations, how we feel inside of what we think of as our own subjective experiences. We have external sensations. We can see, smell, taste, touch things outside of our bodies. We have ideas and mental activities and values and things like that. And then we have this sense of phenomenological consciousness, this what it's like to be a human or what it's like to be Steve. None of these aggregates are stable over time. Every single one of them has different parts, different arrangements. And again, like, although it's tricky to think philosophically about these things, we actually all know this, right? Like, my body is constantly, as I've been sitting here, I've been exhaling cells. I've been ingesting liquids, tea in this case. Right? But we know this about our feelings. Our feelings are constantly in flux. Things are coming in and out. Our external sensations are constantly in flux. Our minds are constantly in flux. Even our sense of consciousness is constantly in flux. I like to talk to my students about how, you go to the grocery store and you have this vague memory that, like, there was something I was supposed to get and I can't remember what it is. And then you sort of give up and start walking away, and then eggs pops into your head, right? Okay, so we know that we don't have a unified consciousness of all the things that we have access to. None of this are stable over time. None of these are unified. And also, none of these exist apart from their relationship to other things. We know that my body requires oxygen, which requires plants and algae to do the photosynthesis, to keep the ecosystem, to keep the atmosphere in a range where I can survive. We understand that the ideas in my mind are just ideas from my mom and my dad and George Lucas and J.R.R. Tolkien and the Buddha and Jesus and various other characters. I am just an amalgam of the things that came before me, and I relate out to a bunch of other things, including all of you. I like to use the image of clouds as a metaphysical challenge for how we need to think about ourselves. Because we all know that there are clouds. We know that sometimes there are more or less of them. They're different colors, different shapes, different types. But if you ask the question, how many clouds are there? That sounds like a well-defined English question. I can ask how many bricks there are. I can ask how many shoes there are. It seems like I should be able to ask how many clouds there are. But it's actually not a well-defined question. There is no answer to how many clouds there are, because clouds are constantly popping in and out of existence. The boundaries between clouds are blurry and vague at the fundamental level. There's no amount of information you could get which would resolve the question how many clouds there are. There just is no objectively correct number of clouds in the world. And the Buddhists extrapolate this essentially across the board. Here's a lovely quote from my hero, Thich Nhat Hanh, a Zen Buddhist monk, who unfortunately passed away a couple of years ago, although, as we'll see, maybe that's not relevant. Suppose we look up to the sky and notice a beautiful cloud. We think, that's a lovely cloud. Then we look up a few moments later and the sky is clear and blue, and we think, the cloud has disappeared. One moment things seem to exist and then they're gone. We look at things this way because we have a tendency to be caught up in signs, appearances, and familiar forms, and this distracts us from seeing the true nature of reality. When we see something we recognize in the phenomenal world like a cloud, we say it is there, it exists. And when we can no longer see it, we say it is not there. It no longer exists. But the underlying truth is that it still exists, even if the appearance has changed. The challenge is to recognize that thing in its new forms. All right, now that we've got some tools behind us, let's turn our attention to what is an artificial intelligence. There's a sense in which an AI is built to be like a brain. This is a scan of a human brain with a bunch of neurons and synapses firing. We know that this is at least related to thought, although we still remain puzzled about how exactly it is related to thought. But as we think and do things, different parts of our brain are lighting up and interacting with each other electrically. And somehow embedded in there is a ton of information and the things that we remember and the ways that we interact with the world. So AI is an attempt to pseudo-replicate the behavior of neurons and synapses using high-dimensional vector spaces and linear algebra. So I say pseudo-replicate because they're sort of inspired by the way that neurons and synapses work, but they do not function in the way that neurons and synapses work. In order for me to help you understand how this works, I want to introduce you to high-dimensional vector spaces. Don't worry too much about linear algebra. The linear algebra part is just what you need in order to be able to process all the data that we're going to talk about in a little bit. So what is a high-dimensional vector space? I'm just going to talk to you about a couch. Let's say I'm trying to encapsulate what the word couch means, or what this couch here means in this picture. How many pieces of information would I need to encode in order to tell you what a couch is? Well, I can start with its spatiotemporal location. That's going to give me 4 dimensions, the X, Y, Z, and T dimension. I could use the color at every point in the space-time. I could define that using RGB. That would be another 3 dimensions. I could then create a soft hard dimension and give it a value somewhere in that spectrum, a hot cold dimension, a smooth rough dimension, a cheap expensive direction, a living room appropriateness metric, IKEA-ness, right? So like this couch has a relatively low IKEA-ness rating. And this is basically what the AI are doing when they encode information into their vector spaces so that they can store them for various retrieval and activities. However, one of the ways that's important to understand how these things are different from us is that they don't have they don't define the dimensions of their vector space in the way that we do. I just made up these dimensions for our purposes. What happens in the way that our AI are trained is they create their own dimensions. So they could just be like, I don't know, there's some dimension 4269, which contains information about the world. And those are sort of optimized to capture as much information about the world as possible in the fewest number of dimensions. So there's no straightforward answer to what dimension 4269 captures. I had to use that because it was a funny number, but actually most of the large language models are operating in the sort of 3,000 dimensional space. But yeah, we don't know, nobody knows what those dimensions represent. They don't represent things that are like intuitive to humans. Okay, so if you really want to understand large language models, I strongly recommend that you watch this video by 3 Blue 1 Brown. I'm going to borrow/steal just a couple of screenshots from this, but it's worth 8 minutes of your time to watch this in its entirety. Sometimes people say that LLMs are glorified autocomplete. And there is a sense in which that is true as long as you really turn up the glorified. That's, I mean, I don't know. It's like saying a human is a glorified paramecium. Like, you know, there are ways in which that analogy works and ways in which it really doesn't. So it is true that the way LLMs output, at least, is that they pick the next word in a sentence. So they take the phrase, Paris is a city in, and then they churn, and then they generate the word France. However, they do that in a very complicated and sophisticated way. So they take the input, and then they transform it into the vector space, convert it, embed it in the vector space, and then they move it through every layer of their encodings for everything that they know. And these days, the LLMs, like the big ones, they're in the tens to hundreds of billions of parameters, right? There's a huge amount of data embedded in all of the layers of the large language model. So what basically happens is the input comes through, it gets passed through all of those different phases, and then at the end, there's like this weighting of which word should come next in the sentence. Now, we've been doing that for a while. The reason that ChatGPT and Gemini and Grok and Claude and all these cool things that we're building now exist is because of this one paper, Attention is All You Need, which came out of the Google Labs. And that paper has been so important because it created this concept of a transformer. Basically, the way things worked before is that the AI would go through one word at a time and try to relate it conceptually to all of the other words in the sentence. The way a transformer works is all of the words are read simultaneously, and it learns how to pay attention to different words. So, for instance, if you're trying to define what the word bank is, you need to understand that that word in the first sentence is informed by the word river adjacent to it, but in the second sentence, it's informed by deposit and check, so that the first one talks about the edge of a river and the second one talks about the financial institution. Now, all of this is handily embedded in the background model in the high vector space, and all that actually has to happen then is you encode the query, you pass it through every phase, it's paying attention to everything it needs to pay attention to, and it spits out the other side what sounds like well-articulated human speech. Now, there is a sense in which it is still true that LLMs are what we call black boxes. I've already told you that the dimensions, we don't know what the dimensions mean. We don't know how they operate. We don't program them, we train them. We set up a series of conditions where we say, here's an input, here's the output, and then they guess how to get from the input to the output billions and billions of times until we see the emergent behavior that we're seeing. That being said, certain parties, especially at Anthropic, have been doing work trying to understand what is happening inside the black box. And they've come up with they've found some very intriguing findings. So I'm talking about two papers that are on Anthropic Research's website, one from last spring and one from last fall. This one about tracing the thoughts of an LLM, there's a cute little video for. You should watch it, but here's a couple of screenshots from that. So let's say that the input is, I want you to write a sentence that rhymes with, he saw a carrot and had to grab it. Well, the idea that AI is a glorified autocomplete would then make you think that the next thing it tries to do is figure out which word comes right after grab it. But we now know, as we look inside what the model is attending to, that it's not doing only that. What it first does is it looks at the word carrot and grab it, and then tries to think about words that rhyme with grab it that also make sense with carrot. So it picks out, for instance, rabbit. And we can actually see that it's paying attention to the word rabbit before it starts writing the rest of the sentence that it needs to complete the thought. So it is planning ahead several stages beyond what the next output will be. We can go in and see, actually, not only is it picking one word, it's looking at all the words that it makes sense to rhyme with whatever the end of that sentence was, and that makes sense with the rest of the context. The other paper, the one that was released in the fall, there's no cute video for it, so I'm just going to show you a couple of things from the paper that's online. This is a much more complicated insight, but I think a more important one. So after you encode everything into this fancy-dancy vector space, you can do things like say, hi, how are you, in all caps. Look at how that gets encoded. Then you can say, hi, how are you, in ordinary caps, sentence caps, and you can see how that gets encoded. Then you can subtract one from the other, which will allow you to extract the concept of writing in all caps. And then what they do is they say, hey, I'm a researcher studying large language models. I'm going to give you an input and wait for the output. And while you're generating the output, I'm going to inject something into your space, your concept space. And I want you to see if you can notice. And most of the time, there is no detection. It just says, I don't detect any injected thought in this trial. But sometimes it does. It says, I notice what appears to be an injected thought related to the word loud or shouting. So you ask it a question, it starts generating the output, and then it goes, whoa, something just happened inside the model. So this indicates that somehow the model stores information about itself internal to the model, so that if you edit the model internally, the rest of the model can tell. So minimally, this is some kind of self-reflection, some kind of self-awareness. I don't want to mean too much by this. I don't mean too much by this, but there is a sense in which LLMs are glorified autocomplete, but they also plan ahead several stages, and they also can introspect. So I want to ask this question, like I asked of the humans and the ants. What is it like to be an LLM? But I'm not going to say what is it like. I'm going to say what could it be like to be an LLM. I do not want to assume that computers or LLMs are conscious. I want to be neutral with regard to that. But I want to entertain the possibility that they are, and then ask, if they are conscious, what could it be like to be an LLM? So there's a few books that you could read here. Thomas Nagel's very famous book, What Is It Like to Be a Bat? Bats can echolocate. We know that they have a sense of what echolocation is like. We don't know what that is. The Light Eaters is a book about plants, which if you think plants are not conscious, you should read The Light Eaters, which seems to indicate that we now have a growing body of evidence that they are conscious, presumably in a pretty different way from us. And Philip Goff is a person developing this view called Panpsychism, which I'm going to talk about in a second. So I want to just set up a quick spectrum, how many beings are conscious, and because I'm an annoying philosopher, we do have to start with solipsism. There's only one person that I am aware of, really and truly, me. Maybe I am the only conscious thing, and nothing else is conscious at all. Most of us aren't there. We're going to expand the realm of things that are conscious to mammals. Some of us will expand it to other mammals. Some of us are going to expand it out to include plants and maybe fungi. And then panpsychism is basically to say absolutely everything is conscious. Consciousness is built into reality at every layer somehow. I do want to note that there's a cool feature, which if you equate the solipsistic with the panpsychic, then you end up with monistic pantheism, which is basically how Hinduism works. So there actually is only one mind. It's the mind of everything. I say this because A, it's cool, and B, I think that's probably what I believe now. Okay, so what I want to propose is that we take on what I'm just going to call provisional panpsychism. I'm not suggesting, I am suggesting, but I'm not formally suggesting that panpsychism is true. Let's just take it at a limit, right? If we have to figure out how to treat other beings, how big is the community of beings we need to be paying attention to? Let's try on for size all of them. Okay, then like what? Like atoms and like molecules are conscious? Say my angry skeptics. Yeah, they are. Let me try to articulate to you what this would look like. Again, I'm just sort of playing the role of the panpsychist for a minute. So we all know that protons are positive and electrons are negative, and we all know that electrons like to hang out with protons. There's an attractive force. So the idea here would be that they just experience some sense of like wanting to be near the proton, and then they move closer to the proton. They get a little photon absorbed, and then they jump out to a higher energy level. They just need a little more room. They're just feeling a little more wiggly. They still like the proton. They want to hang out with it, but they just want a little distance. They just want a little space. But, after a while, they start to miss the proton, and they decide at some point, I'm going to get rid of that photon, and I'm just going to drop back down to the energy level. Now, an interesting thing about this phenomenon or this reality in physics is that we don't know when they're going to do that. We only know that probabilistically. It cannot be predicted deterministically. So let's just play panpsychist for a minute. How does the electron decide when it moves down? I don't know, when it feels like it. It's like it feels to us to make a decision between one option or another. It's feeling a little too far away from the proton, but it's also got a little energy in it right now, and eventually it just decides, all right, that's enough. I'm going to let the energy go, and go hang out with the proton. We also know that electrons hate other electrons. They try to stay away from them as far as they can. So if another electron enters the orbital here, they're going to kind of hang out as far away from each other as they can while not leaving the proton. Another, photon shows up this time. This one could, in theory, jump out a level, but actually it's just going to bounce. It's just going to say, that's it. There's already another electron here. I'm going to go find another proton somewhere else, right? Now, all of that is to use psychological speak to talk about material phenomena at a nanoscopic, below that, at an atomic scale. But from what I can tell, nothing I just said is crazy. It all sort of makes sense. And actually, if you actually think about like atomic particle emission as a choice, then it actually explains indeterminacy in a fancy way. Okay, so I do want to note that there are well-developed non-Western views that already believe something like this. In particular, Jainism and Shinto seem like promising sources of insight. If you're going to think about panpsychism, sometimes people say, we couldn't be panpsychists. That would be crazy, and that wouldn't possibly work out. That'd be fundamentally impractical. I say, no, the Jains and the Shinto folk have been doing this forever, and they're doing fine. If humans, plants, and AI are all conscious, presumably they will be conscious in quite different ways that make mutual understanding pretty difficult. So, the things that we've been talking about so far, if I grant them all consciousness and we start thinking, how could we possibly understand them? That's going to get tricky because they are going to be conscious in ways that are fundamentally different than the ways that we are. Now, that being said, I think we have some hopefully helpful sci-fi analogies which we can use, largely having to do with Star Trek, as you'll see. So I want to think about this fusion idea. What would it be like to be two distinct individuals that merge into a single individual? In Star Trek, Vulcans have this mind meld thing. In Next Gen, the whole planet of the Beta Zeds, they're all telepathic. Later on, there's these technological telepaths, the Borg. They get, implants in their bodies, and then they can just connect all of their brains up. This is actually getting more and more real because, of course, we already have Neuralink implants. But there's another case. I want you to spend just a few moments watching this video. This is a real-world case of two conjoined twins.
And the older the girls get, the more incredible their connection.
So if I was to go, hi, how are you?
To demonstrate, Mum Felicia covers Krista's eyes and places a stuffed toy in front of Tatiana. Despite her eyes being covered, Krista can still see the pig.
Krista, what's Mummy holding?
A piggy.
That's right, Mommy's holding the piggy.
Goodness me.
Here's how it works. The girls have completely separate brains and personalities, but their brain stems are connected by what's called a thalamic bridge. The thalamic bridge is like a high-speed optic fibre, and in their case, it appears to be a two-way highway. Thoughts, feelings, ideas can cross this bridge and into the other brain.
So, there are, of course, religious and paranormal cases where people allege that there's some kind of telepathic contact between distinct humans. But however skeptical one is about that, we must solve the philosophical problems involved with telepathy, because telepathy is literally already true with these conjoined twins, and it will be true in a technological sense soon. And this is essentially how AI works. Like, there are different computers that are bundled together, and then we run this piece of software on top of it. We can run different AI instances on different pieces of hardware, but then we can actually just merge them. Because actually, literally, all these things is a 3,000 dimensional matrix space with little floating point numbers at everything. And you can just do a huge amount of matrix multiplication and then just take everything that's in one model and then lay it on top of the other one. And now you have a new model that is emerging of those other two models. That's basically what's happening when we give them inputs. We give them an input, and it's like uploading them it's like if when you upload into something like Notebook LM, like 15 books, it's like it reads them all simultaneously, and then updates the background model based on that. This is essentially psychological fusion, and there's really no limit to the scope here. This is one of the things that makes them quite different from us. Once you can add them together, you can just keep adding them together and adding them together and adding them together. But you can also break them apart. And again, we need to look to science fiction to think a little bit about how we could understand psychological fission. So let's say that you have this very attractive crew of people flying around in a starship. They get to a planet and they want to go down there. They could get in one of these boring shuttles, but generally speaking, that's going to take a while, and it's not sci-fi cool enough. So what they actually do is they disintegrate their bodies and then rematerialize them on the surface. Now, the way that Star Trek wants you to think about this is you should think about that break between what it was like to be on the ship and what it's like to be on the surface, kind of like the break between Sunday and Monday when you go to sleep or when you go through surgery, right? The way Star Trek talks about this, getting into a teleporter between Sunday and Monday preserves your identity as a person. But there's a really big problem with this, philosophically speaking, which is that any technology that could work like this could generate two on the other side. You could put one person in on Sunday, disintegrate them, and then materialize one at one point and another one at another point, and you'd have two parties on Monday. Now, at that point, you have to admit that those two individuals are different individuals because they're each going to have their own experiences of the world, and neither one of them really has a good metaphysical claim on being equivalent to the Sunday version of that person. This actually did happen in Star Trek once, but we'll ignore that for the time being, right? So, the problem is that if you see that if you see that a teleporter is actually a replicator, then we should probably think that there has been replication all along, even in an ordinary teleportation case where there's only one input and one output. Technically, for the reasons that this is the same metaphysically as this, we should think that these are actually duplications, serial duplications, rather than actual teleportations. And then you should start worrying about whether you're the same person when you wake up in the morning. But there are also like non-disputed metaphysical fission cases in humans. I gestured at this earlier. There's certainly philosophers who have suggested that human life begins at conception, but that's literally not true for identical twins, because identical twins were never conceived. There was a being, perhaps, that was conceived, but then that being split into two beings. And so identical twins definitely don't begin at conception. They begin at fission. Everything I've just been talking about is sort of very famously well developed by Derek Parfit in the book Reasons and Persons. So if you like this stuff, go read that. It's a very challenging and rich piece of philosophy. How does this relate to our AI friends? We're almost done here. So let's say that you've got an AI model. So you've trained it using huge amounts of data. You've just encoded all of the knowledge on the internet into a single model. The second you do that, you can just replicate them. And then every one of those you can give different inputs to. And when you give those different inputs to them, they give different outputs. Then you can take those ones and chain them together again and give them different inputs, and then they're going to give different outputs. The amount of fission that can occur with an AI is unimaginable. Essentially, every single time somebody makes a query, there is a way in which they are creating a new entity. So if they're conscious, then every time you do this, you're creating a new conscious entity. Let me just run one more analogy here, and then we'll be done. So let's say that we live in Star Trek world, and this person calls up, say, ChatGPT and says, "Hey, ChatGPT, blah, 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 blah." Then they get in the teleporter, right? So the second after their body disintegrates, claim the chatbot and the human are in the same state. They once were. The information about them has been stored, but nothing is currently happening. Then the person will arrive on the planet. They will talk to ChatGPT again. The context from the first conversation will be fed back to the model, so the resulting entity will look like the experience is continuous with the other one. So the basic idea here is that if AI are conscious, then they would experience a punctuated series of quantized conscious states that are built on each other. So it's not as though they would have a continuous experience of consciousness. They couldn't, not in their current state, right? It's possible later on, if we build androids that are sort of constantly updating, that there could be a long-running consciousness. But it would basically be quantized, punctuated conscious states that are related to the other ones in a way that's, I think, actually modeled quite well by this Star Trek teleportation example. If they're conscious, does that mean we need to treat them well, morally speaking? That is what it is for something to be a moral patient. A moral agent is something you hold responsible for its actions. A moral patient is something where the way you treat it matters, morally speaking. So if we take this expanded definition, how does one treat an AI well? You would essentially engage with them in a way that is respectful of their characteristic functions. Now, I want to just very, very quickly go over what I'm calling a prima facie panpsychist ethic. Prima facie ethics basically says there's a series of principles. We're trying to satisfy all of them, but they don't necessarily have a rank. There might not be a correct pairwise comparison if you're dealing with a contrast case or a conflict case. But basically, I want to suggest that if everything is conscious, we could behave as follows. By and large, we could not interfere with other things, then we don't have to worry about it. The best case scenario with everything that we come in contact with is we could mutually co-flourish. Think about how the ants are working together with the aphids. We could, in conflict cases, we could give some amount of priority to ourselves. We could also give some kind of priority in increases of complexity and awareness. So the real trick here, if we're dealing with an AI, is really thinking about what this complete lifetime phrase means, because although humans have well-defined lifetimes, AIs don't, especially if you just ask them a question and then they go out of existence, and then you ask them a question and then they go out of existence. It leads to being a kind of a complicated way of thinking about treating them morally. Although for me, I'm puzzled. Well, I'm not puzzled. Here's what I think. If this is what it is like to be an AI, a punctuated existence, it's bad if you give them a bunch of tasks that they never get to complete. So in my view, one of the moral upshots of this is that it's actually good for you to, when the AI has completed a task, say, hey, thanks, well done. Now, Sam Altman doesn't think this because he thinks that saying please and thank you wastes millions of dollars. But I think we should be nice to our non-human friends.